going to discuss the three basic textures in the Pbr standard. They are color, roughness, and metalness. As the name suggests, we put the color texture in a base color slot, we put the roughness texture in the roughness slot, and we put the metalness texture in the metallic slot. Easy, right? Especially if we are using the Node Wrangler add-on, all textures will automatically go to the slots where they are supposed to go. The thing is, when you download older 3D files or older texture sets, you may not be able to find the roughness or the metalness textures. Instead, what you can find are the specular and glossiness textures. The color textures are also sometimes called diffuse, and other times are called albedo. This condition can lead to a lot of confusion for beginners. But no worries, hopefully after this video, you will understand why they are different naming conventions, and also you will know how to deal with them confidently, inshallah. At the beginning of the Pbr adoption, there were two different approaches for composing Pbr textures, the metallic workflow and the specular workflow. The metallic workflow uses a combination of albedo, roughness, and metallic textures to define a material, while the specular workflow uses diffuse, glossiness, and specular textures to define a material. Both workflows have pros and cons. Years ago, people liked to debate which one was better. But as time goes by, more and more artists and studios prefer the metallic workflow and abandon the specular workflow. Nowadays, most of the time, you'll get this set of textures when you download or purchase textures, although you may still encounter this set of textures from time to time, especially if you are downloading free 3D models that are quite old. So, what is the difference between the two? Long story short, the metallic approach puts all the color information in the albedo texture. This makes the roughness and metallic textures are always one channel or in grayscale color. Where the metallic texture is white, then that area of the surface is metal. And where the metallic texture is black, then that area of the surface is dielectric. When the material is metal, the reflection color is taken from the color in the albedo texture. So it is that simple. On the other hand, the specular workflow divides the colors into two. One is in the diffuse texture to define the surface-based color, and the other one is in the specular texture to define the reflection color. But you will only see colors in the specular texture if the material is metal. For dielectric materials, the specular textures will only have grayscale colors. Alright? The reason why people eventually prefer the metallic workflow is because it is less demanding on memory and computer performance. The metallic workflow only needs 5 channels in total. That is, 3 channels or RGB channels for the color, which we call it albedo, 1 channel for roughness, and 1 channel for metalness. While the specular workflow needs 7 channels in total. That is, 3 channels or RGB channels for the color, which we call it diffuse, 1 channel for glossiness, and another 3 channels or RGB channels for the specular. Another issue is also the amount of image processing for the color texture to be used in a specular workflow. Before the Pbr standards, color textures usually still contained shadows, highlights, and the reflection colors. Most of the time, we want to avoid these colors as they can make the material look fake. With special processing, the shadow and highlight colors can be removed from the image, leaving only the pure color of the surface. The result is what we call the albedo texture. This is the type of color texture needed in a metallic workflow. However, this is not enough for the specular workflow, as we still need to take out the reflection colors and then move that color to the specular texture. The result of this process is what we call the diffuse texture. So again, the diffuse texture is basically a color texture where the shadow, highlights, and reflection color are taken out from it. Now, don't be surprised if you find 99% of real-world materials have no difference in terms of their diffuse and albedo textures. Why? Because only metals have reflection color. And even in a metal family, you will only find two colored reflections, yellowish such as gold and brass, and reddish such as copper and bronze. And that's it. Other metals like aluminum, platinum, chromium, silver, and so on, they all have no noticeable colors in their reflection. Essentially, you will only see the difference between diffuse and albedo textures when you mix the electric materials with colored metals such as gold or copper on a single texture set. Of course, this will be a different story in non-realistic scenarios. For example, if you create a sci-fi or fantasy world in video games or movies, when you are not bound to create realistic rendering, you are free to create any type of colored metal that does not exist in the real world. Okay, so now you understand why there are so many different names for these textures. The way we deal with these textures is as follows. For color textures and their variants, such as diffuse and albedo, you just need to plug them into the base color slot, alright? Please note that for color textures, you want to make sure that the color space option is set to sRGB. sRGB stands for Standard Red Green Blue. This is the default option, so you don't need to do anything about it most of the time. Essentially, if you set this as the standard RGB, Blender will process the data that goes out the node as 3 channels, each 8 bits wide or 24 bits in total. The next texture type is roughness. Again, to use these textures, we just need to plug them into the roughness slot. White colors mean fully rough, and black colors mean fully glossy. Now, one thing that you need to be aware of when using this texture is the color space option. You need to set this to non-color. This tells Blender to process it as a single channel data and not a 3-channel data. Personally, I hate that we need to set this manually, because sometimes we forget to set this correctly and end up messing up the rendering result. I hope in future versions, the image texture node can detect and output the data automatically, but at least with the Node Wrangler add-on, this kind of mistake can be avoided or at least minimized. Now, sometimes you cannot find the roughness texture and can only find the glossiness or glossy texture. As I explained before, these are textures from the specular workflow. What is unique about these textures is that they are the opposite of the roughness textures, meaning that white is fully glossy, while black is fully rough. So, if you want to use this type of texture, then you need to revert the effect using a special node called invert color. We don't have a glossiness texture currently, but let's assume that this roughness is a glossiness texture. To create an invert color node, just press Shift A and then type invert, and here is the node. With this node, we need to intercept the color output data from the image texture and then plug the inverted result into the roughness slot. Again, this is what you need to do if the image is a glossiness texture. Alright? The next texture type is the metalness or metallic. Because we are using a stone wool texture that does not contain any metals, there is no metallic texture in a texture set. This is another reason why people prefer the metallic workflow. That is, if the material is not a metal, then there is no need to create a metal texture. This saves yet one more channel from being processed by the computer. For now, just imagine that this roughness texture is a metallic texture. If so, you need to make sure that the node is set to non-color, and then you have to plug this into the metallic slot. Again, white colors in a texture would be considered fully metal, and black colors mean fully dielectric. Okay? Now, if you find that the texture set still uses the specular workflow, meaning that instead of metallic, it uses specular texture, you can still use it in Blender. You can plug the texture into the tint color slot in the specular group parameters. What makes the specular workflow a bit tricky to work with is that if the material is a metal, the specular texture will contain RGB color. So, in such a case, you need to set the color space to sRGB and not non-color. Alright?